Hello students, welcome back. The last two sections of this notebook concern technology. If you go to 2.1, section 2.1 of our textbook, you'll see our textbook author employing very classical paper and pencil method, producing XY table with various computation and plotting those points on graphic paper and then manually joining them. Well, that used to be the method some 50 years ago, but not anymore. So I don't want you to spend your time doing those. Instead, I want to emphasize this method, Desmos Graphing Calculator. The primary reason I like Desmos is because it's free. You can go to this website, desmos.com/calculator, which I'm already here. Or if you forgot, you can go to any Google search and then type in Desmos or even just Graphing Calculator. And you'll find Desmos because it's very popular. It's free. Also, Desmos produces the free app as well. So you can go to App Store, any App Store, and then download this Desmos for either iPhone or Android for free and install it to a machine. And if you do that, then you can make your phone as a very effective graphing calculator, much better than handheld calculator, which gives you really small screen. Okay, let me do some demonstration. Y equals to 4x to the 6th power plus 5x to the 3rd power minus 2x squared plus 1, okay, that's enough, divided by x to the 3rd power minus 4x plus 2. Okay, alright, I created something really complicated, and here's a graph. And of course, you could never produce anything like this with XY table method with some 50 points on it. And I want to see some structure. So let's zoom out and let's see how things are going on there. Wow, we have some graph forming, but it's really hard to see anything. I mean, I can zoom in to see any microscopic behavior, yes, but the large scale is really hard to see. That's because the graph is too thin. So zooming in or out cannot really help you too much. In that case, I want to stretch this horizontally. How do you do that? Graph settings here, and then y-axis going from -30 to about +30. That looks appropriate. But horizontally, I need about 3 to 3. Okay, all right. You see, I stretched it horizontally a lot. So this is about 10. This is only 1, you see. And then let's zoom out. Do I see some structure? We have one piece, another piece over there, another piece over there. So it looks like we have 4 pieces of curves. But they're still too thin. So let's go down here. So -1000 to +1000. Yet horizontally, let's see, -10 to +10. You see, I stretched really a lot. So this is 5, that's 500. And what do you see? Looks like I have a vertical asymptote here, another vertical asymptote here, another vertical asymptote here. If you don't know what the asymptotes are, it's okay. We're going to talk about those about a month later. At this moment, I'm just demonstrating how to use this Desmos Graphing Calculator, especially this one, graph settings. Zoom out, and I can see some outer structure finally. Increase, and something wild and crazy happens, and then keep on increasing. See, increase, and something wild and crazy, and then increase. Maybe I have to go even further. Stretch it even further to see the outer structure. Increase, something wild and crazy, and then increase, kind of like that. How did it handle all this? By changing the graph settings I did. Well, let's go back to square case. 10 to 10, that too is 10 to 10. We are back to a square case. So how was it for practice or a demonstration? We talked about zoom in, zoom out, and also graph settings. Now, we went through a lot about graph of functions, but we can do a lot of other things as well. How about this example? X squared over 9 plus y squared over 4 is equal to 1. This is not a graph of a function. As you can see, it fails the vertical line test. It's an graph of an equation of two variables that we discussed over here. It's an ellipse. In calculus, we are going to call these kind of curves as implicit curves. Now let's produce another one. Let's erase it. And then let's go down and let's produce the next example. Hyperbola. And I can go back to this one again, or both of them in the same viewing window. I can do that too. Let's go to the next one. Y squared over 4 minus x squared over 9 equals to 1. I can do that too. And then produce this one too, and produce that one too in the same viewing window. And then zoom out and in. You can do various things, or you can erase the others. Anyway, I just demonstrated how to use this Desmos graphing calculator for implicit curves as well. Previously, I showed you graphs of function, but this time implicit curves, and also showing two or more graphs in the same viewing window, or erasing one or more of them if necessary. There are more functions as well, but that's something you'll have to get your own hands dirty and learn on your own by actually going to this website and then typing in, play with it, and learning it. So I'll leave the students now how to study with these Desmos graphing calculators, and by the time I open up my next video, I'll assume that everybody earns some proficiency on it. We're going to talk about the application of it.